The generator is isolation mounted between the frame rails forward of the rear axle housing. The generator is coupled to the engine by a torsional coupling. The generator rotates at the same speed as the engine. Therefore, no speed sensors are installed on the generator. The drivetrain ECM monitors the engine speed, and will use this data to determine the speed of the generator. The generator consists of the following main components. The stator is a part of the generator housing. The stator windings are connected in a configuration that will produce the three phases of AC voltage output. The windings are coated with a resin insulation and are isolated from the stator housing. The voltage is created by the rotation of the DC-charged main rotor windings. The generator rotor assembly is the rotating part of the generator, built around the generator shaft. The main rotor contains the DC field windings that induce the AC current into the stator windings as the rotor is rotated. The exciter DC field winding and exciter stator leads are connected to the positive and negative of excitation field regulator current output circuits. The exciter DC field winding frame is bolted to the end plate of the generator and does not rotate with the rotor. The rotating exciter armature is wound around iron cores. The rotating exciter armature is located next to the generator rotor assembly. The current sent to the field windings from the EFR determines the strength of the magnetic field. The amount of EFR DC output current that is sent to the pole windings is determined by the drivetrain ECM commands to the EFR. This DC current from the EFR creates the magnetic field in the exciter field windings. The greater the DC current from the EFR, the greater the magnetic field, which will result in greater voltage output from the generator. The exciter rotating assembly is mounted on the generator rotor shaft next to the generator rotor assembly. The assembly consists of the ring resistor, the armature with three-phase windings inserted into slots to form the rotating exciter armature, and the rotating rectifier assembly. The armature windings are in line with the exciter stator windings. The three-phase leads from the armature windings are connected to a rotating rectifier assembly. The assembly is mounted on the generator shaft in front of the armature windings. The voltage generated by the rotation of the exciter rotor, or armature through the magnetic field of the DC field winding, is used by the main rotor to create the magnetic field. The rotating rectifier assembly is a full-wave bridge rectifier. The assembly consists of 6 individual diodes and 2 rotating plates. Each of the 6 diodes has a flying lead connection and a base lead connection. For 3 of the diodes, the flying lead is the anode connection, and the base lead is the cathode connection.
Connection point for the rotating field and ring resistor wires to the DC plates. Ring resistor wire. Insulated joint. Negative diode flying lead. Positive diode flying lead. White sheathed exciter AC input lead. Diode base lead connection to the DC rotating plate.
The drivetrain ECM will use the excitation field regulator to control the operation of the generator. The EFR is mounted on the right-hand side of the frame. The drivetrain ECM will send pulse width modulated command signals to the EFR. The ECM command signals will determine the amount of electrical current that the EFR will send to the exciter DC field winding. The range of voltage from the EFR to the exciter DC field winding is 1 to 144 volt.
Electrical voltage creation from the synchronous and brushless AC generator. The excitation field regulator EFR outputs a relatively small amount of DC current to the stationary exciter field winding. The stationary exciter field winding and rotating exciter armature interact via magnetic fields. The magnetic field interactions and relative displacement generates increased AC current that is sent to the rotating rectifier assembly. The rotating rectifier assembly converts the increased AC current to DC current that is sent to the main rotor windings. The increased DC current generates a stronger magnetic field in the main rotor windings. The main rotor windings' magnetic field and relative displacement interacts with the generator stator assembly, creating a further increased three-phase AC voltage. The three-phase AC voltage from the generator stator assembly is sent to the inverter cabinet to power the electric drive system.
The drivetrain ECM will send pulse-width modulated command signals to the EFR. The ECM command signals will determine the amount of electrical current that the EFR will send to the exciter DC field winding. The range of voltage from the EFR to the exciter DC field winding is 1 to 144 volt. A signal of 4% duty cycle to the EFR would result in less than 1.9 amps of current being sent to the exciter DC field winding low generator output. A signal of 95% duty cycle will result in 20 amp of current being sent to the exciter DC field winding high generator output. To allow the EFR to produce the output current to the exciter DC field winding, it must receive a supply of 24 VDC from a 40 amp circuit breaker. The EFR boosts the system voltage up to 144.0 VDC. This voltage is the EFR output voltage on the exciter positive and exciter negative circuits that are connected to the exciter DC field winding. To provide the power to supply the output electrical current, the EFR receives a 24 VDC system control power through a 40 amp circuit breaker. A signal of 4% duty cycle to the EFR would result in less than 1.9 amps of current being sent to the exciter DC field winding low generator output. A signal of 95% duty cycle will result in 20 amp of current being sent to the exciter DC field winding high generator output. The top generator high voltage enclosure that houses the three-phase output cable connections. The three-phase output of the generator is directed to the AC bus bars in the inverter cabinet, through three high-voltage cables. The AC bus bars in the cabinet are connected to two identical traction rectifier assemblies. One traction rectifier is connected in reverse as compared to the other rectifier. The rectifiers convert the three-phase AC voltage to the positive and negative sides of the DC power bus. During machine operation, the generator is cooled by the system cooling airflow. The cooling air is directed into the generator by ductwork that is connected to the non-drive end cover plate.